Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about how the external code memory and data memory can be interfaced with 8051 microcontroller. We already know that the internal RAM and ROM is available in the 8051 microcontroller. Still, if it is not sufficient for some applications, whether it will be required for a higher amount of RAM or ROM, we can go for external interfacing of that RAM or ROM, or both RAM and ROM will be possible. So maximum we can interface 64 kilobyte RAM and 64 kilobyte ROM with this 8051 microcontroller. So inbuilt memory is 128 byte RAM is available and then 4 kilobyte internal ROM is available. Look at the first example, external code memory interface. So code means it's in program memory, that is a ROM interface. Look at the interface. So this is the 8051 microcontroller and this is the ROM we are selecting to interface it. So internally 4 kilobyte ROM is available in this 8051 microcontroller. If it is not sufficient, we can go for the external memory interface. So here external ROM will be interfaced. See, first thing, EA, this is external access pin. So this should be grounded, then only the external memory will be accessed. If it is connected to VCC, it will be act as an internal memory accessing, and if it is connected to ground, it will access the external memory. Look at this. We need to demultiplex the address bus and data bus that should be connected to the RAM and ROM. So look at this first one, P2.0 to P2.7, that is a port to 8 pins. So all the pins will be have an higher address bus. So that is A0 to A8 to A15. So this higher 8 address bus that will be directly connected to the from microcontroller to ROM. Because there is no other signal will be multiplexed, so we can directly connect this P2.0 to P2.7 directly to the ROM. And look at this port 0. So actually port 0 will be multiplexed with memory, address and IO functions. So we need to separate address and data. That's why we are using these multiplexers. Look at this. So the port 0 dot, that is port 0.0 to port 0.7, totally 8 pins will be available. So this is an actually address bus A0 to A7 and data bus D0 to D7. So address bus is a unidirectional and data bus is a bidirectional. So both things should be separated. Look at this. So we are using this D flip-flop and multiplexing things. So the ALE is connected to this. So whenever we have the valid address, so the ALE signal also send it from the microcontroller. What happens? So the whatever the signal present in this port 0, all 8 pins, that will be copied from here to here. That is the latch function. That is 74LS373. So here we have shown only one latch, but actually this have an 8 latches. So each pin will be connected to one latch. So all the latch will be combined and that will be work in the fashion of parallel manner. So once the ALE signal is applied, all the signals present in this P0.0 to P0.7, all the 8 pins will be copied from here to here. That is a valid address that will be retained here. So this acts as a buffer. Once the ALE signal is removed, whatever the changes in these lines will not be affect the output lines. That means it retains the previous value throughout the output till next signal will be arrives. So once ALE is removed, the same address line will be retained in this till the next valid address comes from the port. And then actual signals, this is an remaining cyclic acts as a data bus, so that will be directly connected to this D0 to D7. So from port 0, actual address lines, that is A0 to A7, and the data lines D0 to D7, that will be extracted by using this latches. Again, so this buses, that is a data bus, it acts as a bidirectional bus, and the address bus, it acts as a unidirectional. That is the signal comes from microcontroller to ROM only. There is no signal come from an ROM to 8051 microcontroller through this address line. So address line is a unidirectional and data lines is a bidirectional. Look at this control signals. So we have these three control signals, read, write, PSEN, that is program stroke enable. So for external code memory or ROM, we use only this PSEN because we have only one operation, that is read operation. We already know that ROM only, that is read only memory. That means only read operation is possible in the ROM controllers. So look at this PSEN. So this will be act as a read signal for this control signal. See, due to this separate signals for a ROM and RAM, we have able to interface both 64 kilobit RAM and ROM at a time. Look at this PSEN signal. So this will be given for an OE, that is output enable pin, and then chip select will be grounded. So what happens? So once this read, whenever we need a read operation, this program store enable signal will be given, that corresponding data will be accessed. So this is only a ROM interface. Look at this now, RAM interface. So almost everything is same, only the control signal is changes. Look at this port 0.0 to port 0.7, all the 8 pins. The address bus is extracted and that will be connected through this latch, and data bus that will be directly connected to D0 to D7. And then look at this port 2.0 to port 2.7, the higher address bus, that is the A8 to A15, directly connected from the microcontroller to RAM. So instead of ROM, here we are using a RAM. RAM have two operations will be possible. This is actual RAM is random access memory. So we can access any location at any time. That's why it is called as a random access. And we are able to perform both read operation and write operation. So we need to give two control signals. One is for a read operation and another one is for a write operation. Look at this. So write control signal and read control signals. All are active low signals. So look at this. We have a bar here, write bar and read bar. Whenever we have this 0 signal available in the write bar, then it will be performs this write operation. Similarly, read bar, whenever we have the 0 signal in the read bar, it performs read operation. So at a time it should perform only read or write operation. So at a time read bar or write bar should be 0, not both should be in 0 fashion. So in the ROM location, any location will be selected by using the address bus. That corresponding location data will be readed or writed based on this control signal read bar or write bar. And overlapping external code and data spaces. Look at this. This is the RAM, and we are giving this write signal directly here. And then a read and program store enable, that will be multiplexed or combined, and that will be given for an output enable to map this code memory and data memory with a overlapping fashion. Look at this overlapping external code and data spaces. Look at this port 2.0 to port 2.7, that will be connected an address bus, and then port 0.0 to port 2.7. So the address is extracted by using these latches, and data bus will be directly connected. And just look at this. So we are taking our AND gate. The PSEN and the read bar signal will be given to the AND gate, and the output will be given for a read operation, and write will be directly given. So what happens? So whenever we have a read signal or a program store enabled, so any one value will be 0, that 0 will be passed to read signal, because this is an all are active low signals. Read bar, program store enable bar, and read bar. So what happens? Even any one 0, so read bar 0 or program store enable 0, so that 0 will be passed as an output of AND gate, and that will be make as a read operation. Thank you.